And this is my name card. If you got any question, you can just email to this address, okay? And the first thing first, I will briefly introduce myself. Then I will explain what is biodiesel and why we use biodiesel, okay? Then something about the synthesis of biodiesel. Then the pros and cons of using biodiesel. Then we will have a break. I will go to my lunch. And after the lunch, I will introduce some conventional feedstock for making biodiesel. Is the oil source, the cheap oil source for making biodiesel. And since I mean both Taiwan and the Japan side are located in the sea, actually in the ocean, so I guess cost of oil plant will be very variable in near future. And finally, I will introduce some toxic oil plant that can be grown without using pesticide. So this will make it more economic and eco-friendly if you use this kind of alternative. Okay. So I guess everybody here can understand this slide. And I just want to let you know I have been living in Fukuoka, Japan for over 6 years, so naturally I can speak Japanese. Okay. And the other important thing is I want to show you here the Taiwan Sugar Research Institute is the place that where I made my first batch of biodiesel. So making biodiesel, I mean the synthesis, is not a new story. It's an old technique. Okay, over 30 years ago. And what is biodiesel and why we use biodiesel? Any problem? No? Okay. The first thing is, what is diesel? Diesel actually is not a what, it's a who. Who invented this kind of genius design? It's a genius engine based on compression ignition mechanism. So first of all, you should compress the air inside the cylinder. By compressing, the air inside will become hotter and hotter to reach the fresh point of your fuel. Then you spray your fuel to the cylinder. Because the temperature now is high enough, you don't need to ignite. You don't need to ignite the fuel. The fuel will be ignited automatically and explode to exert a force to the piston. And the system go into the decompression cycle. Okay, this is the basic of this kind of design. And on 10 August 1893, a long story, eh? This kind of design actually ran on peanut oil. So I just want to let you know, vegetable oil and the diesel engine was a match from the beginning. Okay? So it is quite natural to use vegetable oil for your engine, especially diesel engine. Okay? But since turn into more complicated, since the engineer want to improve the oil efficiency, so they narrow down the nozzle hole of the sprayer, the oil sprayer. So nowadays, the modern engine, the biological oil will crack the nozzle of a modern diesel engine because it has a high viscosity. Understand? So from the beginning, it's okay with vegetable oil. But nowadays, since the improvement of the engine, it's no more okay to pour the vegetable oil into your beloved diesel engine, okay? So I just want to explain what is diesel fuel in this slide. And this is the chemical structure of peanut oil. It carries 3 molecules of unsaturated fatty acid. So it's a liquid at temperature. And 3 molecules unsaturated fatty acid attached on 1 molecule of glycerol skeleton. This is the structure of vegetable oil. But this kind of oil, this kind of structure is too viscous for most model engine, as I mentioned earlier. But petroleum diesel produced from fractional distillation of crude oil, and it contains this kind of simple structure with 8 to 21 carbon atom. So it's quite simple as compared to the upper one, and this kind of compound will be less viscous. Okay? Especially when we look at the viscosity, the ordinary viscosity, against the temperature. So you can see the viscosity of petrol diesel is quite stable at different temperature. But problem occurred on the side of sunflower oil. You can see the viscosity rise dramatically at noon temperature. Okay? So this is the problem. So it's time to do the selection. We should modify the engine to fit the oil, to fit the vegetable oil, of course, or to modify the oil to fit the engine. You should do the selection. You cannot take both, right? Here is our answer to modify the oil to fit the engine, because the engine industry cannot be reversed. Okay? It is no way, it's a way of no return. Okay? So we should do something. We should do something to mimic the chemical structure of petrol diesel, right? So the first thing come to our mind is to dissect this structure into 3 molecules and cap the hydrophilic end with a hydrophobic cap. So here is the performance after this kind of conversion. As you can see, the diesel, the blue one is always the best in terms of viscosity. But coming to the next is the coconut oil, When you use coconut oil, I mean the methyl ester of coconut oil, you can see the performance is quite close to the petrol diesel, okay? When we use soybean oil or biscuit is kind of genetically modified soy, understand? Genetically modified soy. So no matter you modify your genome or not, your oil always perform the same, okay? So you can use GMO or not to produce your fatty acid methyl ester with high enough, with good enough performance, okay? And this one is the performance of canola. Canola is, I don't know how to say in Mandarin, canola. Okay, forget about it. You can easily buy a canola oil in your supermarket, and this one is used canola. When it's a recycle, so it's no matter you recycle or not, the performance will be similar. Okay, so you can recycle the used oil from, for example, from McDonald's. To do the synthesis, okay? Understand? And we have to dissect this kind of structure, right? So after seeking for a similar reaction, this is our selection to do something like saponification reaction. This reaction is the process for making sap. Okay, showing here is the photo of Savon de Marseille, with the first commercialized sap bar issue at this point. The southeast France. Okay, it's quite famous for the nature sap. And you can see in French, sap is called sabon, right? And also in Japan, sap is called charbon. It's quite similar. I guess it's from France, or I mean the Japanese word is from France or from Indonesia actually, because in Indonesia they call it sabun. Do you know how to call sap in Taiwan? I mean in Hokkien, not in Mandarin. In Hokkien we also call it sabun. No, so some words in Taiwanese, in Hokkien, is from Indonesia, actually. For example, I give you some example. For example, coffee. Coffee. Do you know how to say coffee in Hokkien, in Taiwanese? How to say, you know? Gabi, right? It's quite different from the English, coffee. It's not coffee, right? But in Indonesia, they call it kopi. It's more similar to the Taiwanese. Actually, Mandarin, for Mandarin, it's called cafe, right? Cafe, it's not cafe, but not cafe. So I guess the Mandarin, the cafe in Mandarin will be from Italian. Cafe. Okay. So not from England, not from English, because English in British people call it coffee. It's quite different from Mandarin. Okay. This is my my personal opinion that SOP is the greatest human invention of all time. Okay, because when we look at average life expectancy through the history, you can find out a dramatic increase during this era. And this era happened to be the commercialization of SOP in the US 1837, right? Ivory SOP. In Japan, 1819. And here is the first SOP in Taiwan. Okay? It's all because a submolecule carries this kind of non-polar tail and a polar head. It's an amphiphilic structure. It can attach the bacterial membrane by its non-polar tail and being washed away by using water. Okay? So using SOP can keep your skin, can keep your body surface free of bacteria and free of infection. So this is why SOP, the commercialization of SOP can elongate the human lifespan. Okay? And it is now time to turn this kind of great invention to another kind of great invention, biodiesel. All you have to do is to replace water for making SOP by using methanol, okay? And this is the product. Is to replace the water-soluble hydrophilic head with a hydrophobic oil head methoxy group, okay? And then the molecule can be poured into your diesel engine, okay? Let's talk about some detail about the synthesis. A little bit boring, but I'm sorry, a little bit organic chemistry. This is the molecule of triglyceride. It's the basic structure of your oil, the vegetable oil, for example, your peanut oil. This is the process for making SOP. The first thing is to perform what we call hydrophilic attack on this spot, the carbonyl group. Then after some rearrangement, we got one molecule of some molecule like this way, okay? Then the process performed twice, you can get 3 molecules of some molecule, okay? So the alkaline, I mean the hydroxide is the reactant for making SOP. Okay, a little bit different, but for making biodiesel, the first thing is to remove the proton from alcohol using the alkaline, the base. After doing so, you got alkoxide. And it is the alkoxide, not the hydroxide, that perform the so-called nucleophilic attack. And the similar thing occur 3 times. You get 3 molecules of alkyl ester, the biodiesel fuel. Okay, so it's quite similar. But finally, the base will come back, since the base is the catalyst. Okay, a little bit complicated, but I think it's okay for most of all. So now we learn this kind of knowledge. Now we're very happy to run into a supermarket to buy some oil, like canola oil, right? Or you can collect the oil from the field, and to buy some methanol for racing car, and buy some lime. Then we start to mix up all together and pray to the God, but nothing happened. Actually, I did it before, 30 years before. Okay, because this kind of reaction system is three-phase heterogeneous reaction. We got vegetable oil as the oily phase, okay? And we got methanol as the hydrophilic phase. And we got sodium hydroxide as the solid phase. But unfortunately, the reaction occurs only on the interface. So it's quite restricted. I mean, the possibility of effective molecular collision is quite low at this kind of situation. Okay? So the reaction occurs very, very slowly. So a possible solution is to reduce the phase to two-phase. So here is our solution, is to dissolve sodium hydroxide as a solid, right? We use methanol to dissolve, to become one phase. Then we mix these two phases, and the whole thing turns into a miracle. Okay? You can see the reaction occur on the interface of an emulsion like this kind of balsamic vinaigrette. Do you know balsamic vinaigrette is a dressing for salad? Understand? It's actually an emulsion with water, with hydrophilic phase inside. In this case, the vinegar inside. But during the synthesis of biodiesel, inside the emulsion will be the methanol and sodium hydroxide. Okay? And the reaction occurs at the interface on the borderline. Okay? So it is the methoxide that perform the nucleophilic attack on the triglyceride, the vegetable oil, then turn into the product, the biodiesel fuel, which is hydrophobic, is oily, so it will get back into the oil phase, and the glycerol will return into the hydrophilic phase, the inside of the emulsion. Okay? So it's a beautiful, beautiful reaction with reaction and a separation coming simultaneously. Okay? So it's actually a very beautiful reaction. You don't need to separate the product from the starting material. Okay? And this is almost the real thing happened during your synthesis. The first thing is to dissolve sodium hydroxide with methanol, right? Then we mix the oil with methanol all together. Without mixing, you can see two layers. The upper layer will be methanol since it has a slightly lesser, smaller density, okay? And the oil will have a slightly higher density, so upper layer will be the methanol. And after mixing these two components, the reaction occurs, and the product, the methyl ester 3 molecule, methyl ester, right, has a higher and a larger volume as compared to glycerol, the glycerol counterpart. And the methyl ester has a slightly, not slightly, a smaller density, okay? So the methyl ester will floating on the top of the glycerin. And this is our object, our target component, okay? And we draw up the glycerin because we don't want glycerin. Somebody want, you can sell it to somebody. Glycerin is a good thing for in food industry, okay? And you can wash the ester with water because there still has some impurity, hydrophilic impurity inside the ester layer, which can be removed by washing with water, okay? And because water has a smaller boiling point as compared with the ester. Ester has a boiling point about 150, okay? But water has a boiling point of 100, right? So you can evaporate water after the purification. Understand? You can easily evaporate water, okay? And finally, you got a purified methyl ester as the fuel of your diesel engine. And this is a protocol provided by Utah Biodiesel Supply. The first thing is to heat the oil to about 55 degrees centigrade. It's slightly lower than the boiling point of the methanol because you don't want your methanol to be evaporated before the reaction, right? The boiling point of methanol is 65 degrees centigrade. So this temperature will be 10 degrees centigrade lower than the boiling point of the methanol. So this safe to before the mixing, okay? So after the mixing, you got a lower layer as glycerin. After draw out of the glycerin, you wash the upper layer with water and get the biodiesel. Because it contains some water, you should dry under the sun or with the aid of bubbling. You can use bubbling. You can bubble air inside the biodiesel to remove the water, since the water has a lower boiling point as compared with your biodiesel fuel. Okay? Understand? Okay, later I will show you a video for making biodiesel. Let's go through the PowerPoint first, okay? If you have additional question, you can first have a look at the review written by myself a long time ago. This is also SOP with the protocol of TLC analysis, the reaction product, also long time ago. But after my work, there is a startup company making biodiesel. He's the first biodiesel plant in Taiwan. Showing here is the former Taiwanese president, Taiwan President Chen Shui-bian, right? And this company is actually a branch of an oil company for making soap. It's also a soap company. So they are doing a similar thing. If you are interested in research, I guess heterogeneous catalyst is quite popular because alkaline is the catalyst, right? It's not the reactant. It can be recycled. So if you use heterogeneous catalyst, the alkaline can be easily recycled, like this way. I use volcanic ash to attach the alkaline and serve as the heterogeneous catalyst. The volcanic ash was collected from Sakurajima in Kagoshima County, Japan. Okay. It is also my work several years ago. And this is also a particle to analyze the progress for making biodiesel. Okay, now the process comes of using biodiesel. Okay. Biodiesel has a good solubility in petrol diesel. You can practically blend with different proportion of biodiesel. For example, here is the almost a pure biodiesel, 99% by volume of biodiesel and then 1% of petrol diesel. And this one will be 20% by volume of biodiesel and 80% of petrol diesel. And this one is pure biodiesel with certain number of 40, I will explain later. Okay? It's all because you know that the production of biodiesel will depends on season. Understand? It's not very constant. So the flexibility is quite important because the amount of biodiesel will fluctuate. So sometimes B99 will be used up. In this case, we should use B20. Okay, but pure biodiesel is slightly higher than petrol diesel in terms of the price or the cost of production. So this is what we call B factor is important to prevent adulteration. And then the next slide is also my research by using electrochemical manner to sense the B factor. Actually, we can learn from the spectrum. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. We can learn from the spectrum of the B factor. to know the B factor in second, within 3 seconds actually, okay? But I don't want to go into the detail, it's a little bit complicated. And now is the calorific value. It is the heat can be emitted by 100% burning down the oil. For biodiesel, it will depend on the feedstock you use, but roughly will be 37 megajoule per kilogram. A little bit lower than the regular diesel. Okay, the number 2 ULSD, the ultra low sulfur diesel. You know, in the use of the content, the sulfur content is quite restricted because it will emit sulfuric acid after burning. Sulfuric acid, you know, 硫酸. It will turn into acid rain if you use the fuel with high sulfur content. So for fishing boat, it will be okay if you can use a fuel up to 1% of sulfur. That's no problem. For cargo ship, 1.5%. Okay. But for your car, the sulfur content should be restricted. Okay. And of course, biodiesel doesn't contain sulfur, so it's quite eco-friendly. Okay, and the sulfur content will add additional lubricity on your engine, so the ship like it, right? And talking about lubricity, you can see the structure of biodiesel carrying this kind of additional ester bond. And this will add lubricity into your fuel. So biodiesel is in itself a good lubricant. So if you use biodiesel fuel, you don't need to add lubricant like this one, right? But however, over time, the ester functional group will be oxidized to lose some lubricity, okay? So anyway, talking about lubricity, biodiesel is a good thing. But talking about viscosity, biodiesel is still not suitable for the common rail fuel injection system for your high-class diesel car. Understand? Because they need a higher pressure to ease the optimization of your fuel, as compared to 100 bar for conventional fuel injector. Okay. So if you can afford the high-class diesel car, you should only use petrol diesel, unfortunately. And if you run your diesel car in Hokkaido or someplace like Canada, the jarring problem will occur on several kind of the oil. For example, the oil made of soybean. You got crowding problem, okay? But for canola oil, that's okay. Because the crowd point of canola oil is minus 10 degrees centigrade. Okay, because it's made of canola oil is the oil of Canada, so this will be safe in Canada, right? But for Taiwan, no problem at all, okay? And this is the material compatibility because biodiesel is a good fuel, good solvent. And it will dissolve hydrophobic material like especially natural or nitride rubber or polypropylene or polyvinyl or Tyco material. So pure biodiesel may degrade some hoses, gaskets, or glue with prolonged exposure. But after 1993, almost all cars, I mean the elastomer used in almost all cars are compatible with B100, okay? So there is no more question of using biodiesel in terms of material compatibility, okay? And talking about safety, showing here is the picture of, we call it shojugeya. It's in English, it may be a flaming alcohol chicken. It's to put some chicken meat and with some sake, rice liquor, rice alcohol, okay? It put all together and heat the mixture to the flash point. Understand? Because with lower content of alcohol, you need to heat the mixture to certain point to be ignitable. Now after reach the flash point, you just strike a match and the alcohol inside the soup will be burned down and the whole mixture will turn into a delicacy, okay? On the other hand, for example, here is the flaming cocktail. Flaming cocktail has a high alcohol, right? So you don't need to heat. You just strike a match. Then you can demonstrate the show, okay? This is Bodega, okay? So the higher the alcohol content, the more dangerous, right? So gasoline is quite dangerous in terms of the flash point, okay? But for petrol diesel, it's quite safe. Biodiesel, even safer, okay? So here's the summary of the merit and the demerit of biodiesel or ULSD, the petrol diesel for your car. In terms of the flash point, the winner is the biodiesel. And for the certain number is the speed of burning down your fuel in your engine, okay? The higher the speed, the higher the power output of your engine, so the better the performance. So you can see the winner is still the biodiesel. Since biodiesel has additional ester band, it has an ester band, so the structure will be somewhat zigzag. it allows oxygen to penetrate through your oil molecule. So it will be quicker to burn down the film, okay? And for sulfur content, biodiesel, of course, is the winner. And for viscosity, I guess, we still prefer the petrol diesel. And for heating value, maybe the petrol diesel will be a little bit better. The other merit of using biodiesel is it can clean oil spill. Okay, let's look at a picture. A seabird lying there, a dead seabird on the beach, right? Do you know why the seabird is dying? You know why? It ate too much petroleum. No. Petroleum is not too yummy to eat, right? Actually, the bird want to catch the fish in the ocean, and they dive into the water, right? They dive into but the water, there is petroleum floating on the water, and the wax on the further will be dissolved by the petroleum, and the bird lost the wax, and the wax is to keep the body temperature. Okay. So the reason of its death is losing the temperature. Okay. It cannot keep the temperature because it's so cold out there. Okay, understand? But I just want to say there are too many problems of the oil spill. So we got to do something to clean out the oil spill. And the biodiesel is a good solution because it's a good solvent for petroleum. And it has a lower viscosity. And it has a lower density. It can dissolve the oil. Then the mixture will float on the sea surface. That will be easy to be skimmed out. Okay? Understand? And also, biodiesel is biodegradable. So here's the picture of the experiment conducted by the Spanish group. Actually, this is where the northwest coast of Spain, here is where they conduct their experiment to use biodiesel to clean the oil spill on the rock, okay? So biodiesel have additional benefit to be served as bioremediation agent for the oil spill, okay? Of course, biodiesel can reduce greenhouse gas. If we use soybean oil, this will lead to a 57% reduction in greenhouse gas. And if we use waste grease, the recycled soybean oil, even higher, the result, okay? So after, okay, let's show you some video for making biodiesel. Okay, and then we will have a lunch. After lunch, I will introduce lunch, conventional feedstock for making biodiesel. Okay? Okay. Any question about the process? I mean the synthesis and anything, any other thing about the biodiesel? Okay, it's no. Actually, we use a relative pricey oil. You don't need to use this kind of oil. It's quite expensive, but it's relatively dark, so it's quite easy to demonstrate. Oh. So after the mixing, you got 2 layers separating gradually. It's not so fast. It takes time, okay, to separate. So you can see here is the layer, right? Okay. If you use soybean oil, it will be hard. It will be hard to explain. This is to decant the upper layer. Actually, a better way is to withdraw the glycerin from the bottom. Okay. And this is to use water to wash the product. Actually, the better way is to spray. To use bubble, to use droplet to do the extraction. So there still have several impurity residing on the upper layer, and this impurity will be extracted into the water layer. Okay. Like this way, it's an emulsion. Okay. So you can start separating. The upper layer will be the biodiesel, and the lower layer will be the water phase. In this case, this will contain a little bit water inside, and this clear part will be dehydrated biodiesel, and ready for your diesel engine. Okay, this is the video showing how to perform the TLC to make sure your synthesis is on the right track. Actually, this is his first time to do such kind of things. So it's not very skillful. I'm sorry. So we should spot the sample onto the TLC plate. And to develop on a chamber with a solvent inside. Okay. So here's the way to verify the process for making biodiesel. Okay. Any question about this section? Any question? You can use. Okay.
Hi, Professor. I want to ask about the socio-economic effects of the large-scale biodiesel production in Taiwan.
You mean the social ecological economic effect? Actually, we don't have many in the company synthesizing biodiesel. So for the time being, there is probably no effect on Taiwan. For example, now Taiwan using solar cell or wind turbine to produce electricity, right? But it's still it have the drawback of using the wind turbine will have some negative impact on the ecology on the sea, right? And also the solar cell. But for a biodiesel, for the time being, no, because we don't have enough amount of that biodiesel. Okay. Of course, it will compete with the food industry, but for the time being, it's okay. I guess it will be benefit in recycling, the recycle. Because the waste grease, the waste oil, for example, waste oil from McDonald's or from Kentucky Fried Chicken, that's not a good thing. We should recycle and reuse as a soap or as a biodiesel. Okay. Okay. If there is no question, let me go to eat some lunch, and we'll be back on 12:45. Okay. 12:45. Okay. I'm starving. Okay. See you on 12:45.
You said that there's like high viscosity for
a little bit late. There are many people out there in the convenience store. Okay. So it's okay to get started. Okay. Okay, the next section is conventional feedstock. Oops. Okay, before introducing the conventional feedstock, let's have a glance of the biodiesel industry. The first, you should get some oil source. So this will be somewhat we have economic and environmental concern, like the previous question, and. Then we get into the synthesis. It's a technical problem. It's actually there's no important technical problem at all. Then is the purification problem. Then we go to the commercialization and the promotion. And the whole process, we know the major obstacle is in the gathering of oil source. So as you can see, my research actually is nothing at all. So we should aim our obstacle on how to get the enough but not too much, the oil source. Okay? A perfect thing is to do the recycling. And here's the data from Environmental Protection Administration of Taiwan. Each year we got over 25,000 tons of waste oil, waste vegetable oil mostly, from night market, from store, from restaurant. And roughly 40% of which will be exported to Spain, Malaysia, and Korea. And about 60% of which will be recycled as soap or methyl ester, for example, for the as a lubricant, or as biodiesel to be exported to foreign countries like England, Netherlands, Spain, Malaysia, or being used by domestically. Okay? And this is far from enough. Okay? So basically, we can do our best to recycle our waste oil. For example, you can get the waste oil from Kentucky Fried Chicken. Then honestly, your engine will have the flavor of fried chicken. Actually, it's not kidding. And you also can get the oil from coffee ground. Then your car will have an aroma of maybe Starbucks. Okay? But this is far from enough, so we start considering some conventional oil crop for gathering satisfactory amount of vegetable oil, and this is a list. The data from Wikipedia. We can know that on the top of the list is the oil palm. I will explain the red one later. It's quite interesting, okay? And the second one is coconut. The coconut is quite similar to oil palm, but you will see the difference right, later, okay? So I guess chufa is my favorite. I will, something may think about the Chinese tallow and the hemp, okay? And this is the productivity, the yield per hectare, the area of land, okay? Understand? The yield, the productivity per area of land, okay? Per hectare, okay? So we all are very familiar with the rape. Rape is something like this. It's in Japanese, it's called nanohana, I think. Nanohana, okay? And the flowering, the blossom, well, depends on when you sow the seed, okay? So it happened to be the flowering season, blossom season of cherry, okay? Sometimes it can be autumn, okay? Be summer, okay? And this is the photo taken in Luping in China. Luping, China. They are growing canola, okay? A kind of genetically modified organism of rape. It has a high productivity like this, okay? And don't mix up with this one. It's different, right? It's not oil crop. Okay, now I will explain the red ones one by one. The first will be oil palm. If you got an experience of using this kind of soap, Palmolive, don't believe it's made of olive oil. No way. It's too expensive. It's made of palm oil from the plant, the oil palm. Okay? It's a somewhat disgusting plant. Carries kind of disgusting fruit rich in oil in a shell as the kernel oil or in the mesocarp, the palm oil like this way, okay? And this is highly productive. And you can see Borneo. The Borneo Island, the biggest island in South Asia is Borneo, no? And it's the home of orangutan. Do you know orangutan? Orangutan. It's actually it's not in English. It's I think it is Bahasa Indonesia. In Indonesian, orangs mean human being. Human being. Udang means forest. A human being living in forest is actually an apes, a kind of apes living in forest. In the forest of South Asia, especially in the Borneo Island. But unfortunately, you can see the forest has become the farm of oil palm. So the orangutan are losing their home, the forest. So they are weeping for their home, okay? Okay, so this is the problem of the production of biodiesel, okay? If you want to do the production, they will compete with your ecosystem and also your food source, right? And this is another news from Indonesia. You can see the Indonesian government, they want to establish new oil palm plantation about a fifth the size of Borneo. Okay, they want to run all the Indonesian diesel engine with all biodiesel. Okay, but there will be a problem like this: the deforestation in Indonesia. Okay. But I think they didn't consider about the electric vehicle, okay? So I guess biodiesel is not bad, but we should consider a balance. Some place, for example, some place rich in forest. For some place rich in forest, you don't need to use solar cell, right? We should plan. We should use plantation to green our future, not to use solar cell. It's ridiculous. So as you can see, the first one is oil palm, and you can also see the orang-utans are weeping for their home, right? And I know you all know what is coconut, so I skip this one. Let's get into chufar. But it's quite unfamiliar for Oriental people. But chufar is a good meal. Let's start from introducing the flower. The flower is actually a photo taken by myself from the window of bullet train at Taichung Station. Okay? But what are those flowers in the autumn? Nowadays, in this season, no? Okay, maybe it's this one. In Taiwanese, we call it guabang. Okay? But in Japanese, it's suzuki. In English, it's silver feather. It's something like this way. Okay? And that cannot be silver feather because this kind of rush grow on mountain. Understand? So there is a Taiwanese song called "Swating e Guawang Jam Jam Ang," right? This guawang grown on mountain, and they turn reddish during the autumn, right? Something like that. And maybe they are ogi. In English, they call it silver grass. Quite similar, right? But it only grow in temperate zone, not in subtropical region like Taiwan. Okay, so it cannot be silver grass. So how about this one? Ash reed. Okay, probably, right? But if you look at the color of the flower carefully, a little bit different in color. So it is not, unfortunately, it is not wheat, and of course not rice, not rice. So this is the right answer. It's kind of sugar cane. It's not the sugar cane. It's not a commercialized sugar cane. It's the original sugar cane with a smaller stem and a whitish flower. Okay. No, I just want to say there are so many kind of plant belonging to Boaceae family. They are highly productive. They can produce sugar by sugar cane. They can produce starch by rice. They can produce cellulose using reed or rush. Okay, they are highly productive. We can use this kind of family, right? But how about oil? Can some strange species produce oil? Okay, let's look at the other family with triangular stem, but belong to the same order. We got an interesting species called Java grass. Java is the biggest island in Indonesia, Java Island, right? So this is what we call tohyung. In Taiwanese, we call it tohyung. It's actually a nightmare for farmer. It can grow practically on every kind of surface, like Roger Federer in a tennis court. It can practically play on all kind of surface. Okay, and that is very easy to grow. And they carry a nut on the root, so it's hard to dig out. So it's a nightmare for every Taiwanese farmer. But a cousin of Java grass is what we call, in Chinese it is called yellow. This yellow tohyung. This is the Spanish word chufa, okay, chufa, and in English it is called tiger nutsedge, okay, similar to Java grass, but it carry this kind of seed. This kind of seed is edible. So in Japan, it is called shokuyo gayatsuki. Gayatsuki means the Java grass. Shokuyo means edible. Okay? Understand? And okay, let's show you some breakfast, the Taiwanese breakfast. This is traditional Taiwanese breakfast with this is soy milk. Okay? Soy milk with I don't know how to say it in Mandarin, but in Taiwanese we call it yujiagui. Soybean milk with this kind of thing. Okay? In Spain, we got this one. I forget how to call it in Spanish, but maybe it's chudro, I think, something like this. Chudro. Okay? But the Spaniard eat churro with hot chocolate, not soy milk, you know. And I guess this one, churro, this is practically a Spanish version of yujiagui. I'm wondering if it is from China, actually. Maybe you can have a test if you have the opportunity to visit Spain. Okay, another kind of breakfast in Spanish. In Spanish, they call it horchata de chufa con pan. Pans mean bread, and they eat pan with horchata de chufa, the extract, the juice of the tiger nuts. It's kind of oily, contain oil in the seed. Okay. So it's a good match. Oil without oil, oil without oil, oil without oil. It's a good match. So as you can see, for example, here is the Spain. In Valencia, they got the famous Spanish cuisine, paella, right? Paella. And some orange, Mediterranean orange, naranja de Valencia, right? And of course, the chufa. So chufa is quite familiar to a Spaniard, okay? And they are highly productive. The chufa is quite, it's not expensive, it's very cheap breakfast in Spain, okay? So I guess you can extract oil by growing chufa, and that is quite easy to grow. That I will show you later, okay? The third one is Chinese taro. So what is Chinese taro? You can see this kind of tree with brackish trunk and carry this kind of oil seed. It's the best wood for making top, Also the furniture, because it is very homogeneous. I mean the texture. The wood texture is quite homogeneous, so it's good in balance if you got the right geometry, okay? And it is a cousin of poinsettia. Poinsettia, you know this? I don't know how to say. I believe in Japan they also call him poinsettia, maybe something like this, but we call it 圣诞红 because it's turned red. The leaf turn red during the autumn, like the Chinese taro. And this kind of plant is also very high productive, okay? In Taiwan, we call it Kingachu. This is something different, but here is the Japanese name, Nanking Haze. So this will be a good choice. And the final one we got here is the hemp. And we should describe it a little bit further, because this is the Chinese character for hemp, Chinese character. And this one means forest. And this is a restricted place, okay? Which means hemp, this one, can be cultivated in a limited place to become a forest. That is why Chinese people call it hemp, ma, okay? Understand? And this kind of plant can inhibit the growth of weed because they grow so rapidly. You don't need to use herbicide. So it's agrochemical free for cultivating this hemp. So you can obtain both cellulose and oil from the seed, okay? Okay, showing here is a photo in Miyagi-Take Shrine at Fukuoka. You can see hanging there is the rope made of hemp. It's all because hemp is so high productive. So they worship hemp as a symbol of fertilization, productivity. Okay? So they worship hemp in the New Year Eve. Okay? So you can see hemp is so productive. It can produce fiber, oil, or to be served as food. But actually, it's not very tasty. Okay. But why don't we grow hemp? That is all because hemp has a cousin called marijuana. The marijuana carry this kind of psychoactive ingredient is called tetrahydrocannabinol. Understand? So smoking THC make you high. Understand? It's that is why Japanese people call psychoactive drug as mayak. Understand? Because hemp, actually the cousin of hemp, contain this kind of psychoactive drug. So maybe hemp have his future as a highly productive plant for both cellulose and oil. As you can see, here is the worm mat. And the blue one is marijuana legalized. It is okay to take marijuana, for example, in Canada, okay? But it's prohibited in China, of course, including Japan, Korea, and Taiwan, okay? But considering the hemp acreage, you can see the top in list is China. So China, they grow hemp to produce the product they wanted, but they prohibit marijuana. Understand? It's a good selection, you know. But because they look too similar, you can grow marijuana. You cannot tell marijuana field from hemp field. Okay, that's the problem. Okay, So this is it's not a fault of Japanese person. I'm sorry, but it's Vietnamese tragedy during the World War II. You can see there's been Japanese troops. They forced them, the Vietnamese people, to use our paddy field to plant hemp, and they have a hemp and they have nothing to eat, and many people die there and have to wrap the corpse with hemp. So hemp is so productive. Even you don't have anything, you have nothing, but you can have hemp. So let's say this is our tradition to wear hemp clothes to say goodbye to your dad and mom, right? During the ceremony, because the people is so poor, only can wear hemp, but they also get enough money to buy the corpse, buy coffin for the corpse. Okay, understand? That's the reason. So don't forget about hemp is a good candidate for biomass energy. So if I have to choose, this is my choice. If you consider the ecosystem, it's better to grow algae or herb than arborists. Understand? Because you can change the field very frequently. Once you grow the arbor, the tree, you cannot change very frequently, and there will be impact, either positive or negative, on your ecosystem. Okay? So for herb, I prefer this one. Chufa is not only yummy but also highly productive, right? And for arbor, I think Chinese tallow is a good choice because oil palm cannot grow in Taiwan. They will die during the winter. Understand? We cannot grow oil palm only because we have winter. Okay. So this is news from Biodiesel magazine, saying it is Benjamin Franklin, who introduced Chinese tallow into the U.S. and talking about the benefit of growing this kind of highly productive species. They want to extract oil from the sea and they use the wood to make furniture, right? And also, in a recent Biodiesel magazine, saying that a U.S. company, a startup company, they are planning to grow chufar. Where is chufar? Oh, here. Cyprus esculentus, it is chufar. The scientific name of chufar, right? The company, this is the company name. What is the company name? A bioeconomy company, they want to grow chufar to retrieve the oil. So the company is thinking what I'm thinking, understand? They are thinking what I'm thinking. Chufar is a good thing, not only yummy, but also highly productive. And it is a good candidate for making biodiesel. Okay. In the next section, I will introduce some coastal oil plant. There will be many very interesting for Taiwan or Japan. As you can see, here is the map of South Asia. Do you know this island, Ituaba? Does anyone know this island, Ituaba? In Mandarin, it is called Taiping Dao. Understand? But in the world, nobody knows where is Taiping Dao, but somebody know where is Ituaba. It's a formal name of Taiping Dao. Okay, understand? So what is Ituaba? Ituaba in Indonesia means, what is that? So nobody knows what is that. Understand? A poor island. But it's a treasure island because in the surrounding there are many oil content. Understand? So several countries are rushing this place to seek for the oil source. Okay? So you can see South Asia is practically, the whole South Asia is practically on the sea. Okay? So sea, the coastal plain is quite important for us. As you can see, also in the northern part, you can see they still have many islands. There are several interesting, like this one. Does anyone know this island? Pescadores. This is a Spanish name, you know. Pescadores means fishermen. Understand? So the Spaniard passed by this island and found many fishermen. So name this island as Pescadores, right? So here are many Spanish names like this one, Parecevera. Parecevera means it looks like a sail. The geometry, the geometrical form like is a triangle, you know. So here the other island, most of them are Japanese style, the Japanese name, okay. And in this area, there is a Japanese custom to hunt whale, okay. So do you know why Japanese people hunt whale? For food, of course. But American Army also hunt whale. So why? American Army, they hunt whale more than Japanese people. Why? So here's the price of whale meat. Not so pricey, right? 1 kilogram, 1,000 yen, Japanese yen, is quite cheap. About 400 Taiwanese yen. Not very pricey, right? But American Army hunt whale not for the meat, it's for the wask inside their head. The wask inside the whale head is for what we call sonolocation. It's for, you know, a whale dive deep into the water, but for certain lands, for certain they cannot see anything because there is no light deep in the ocean. They use sound. They use sound, and to look, actually to look the position of the maybe squid, right? And the sonar location depends on the WASC in their head. Understand? And there is a WASC. This WASC actually is a fatty acid ester with temperature independent viscosity. So it's very, very good for as the lubricant for airplane. Because air rise high into the sky and down into the land, and they will suffer a dramatic change of temperature. So they need a lubricant with constant property at different temperature. Understand? And the wax in the hand of the whale happen to be carry this kind of property. Understand? And but now, American Army doesn't hunt whale anymore because they found an interesting plant called jojoba. This kind of plant carry the wax with similar structure with whale wax. Okay, so they found an alternative for their airplane. Understand? And you can see whale wax, no matter whale wax or jojoba oil, is quite similar to your skin. Your skin also carry wax on your surface. Okay? So different from, for example, olive oil. You can also give some olive oil on your skin, but it will be much better to use oil, actually the wax like this, jojoba oil. So jojoba oil not only good for the American airplane, but also as a cosmetic. Understand? So now we got a perfume, no, not perfume, I guess. Soap. I think this is soap or body gel called Nice Jojoba, right? You can find it in the market, and in the supermarket we got a brand name called Jojoba, the body gel. They can serve as a good body gel because the structure is quite similar to your skin. Okay. And the most important thing is they can be grown on the place like this. They don't need highly fertilized soil. They can grow on the place like this. So in the U.S., the American people call it goat nut. Because goat can only be grown on this kind of place. Understand? Goats. You cannot grow cow in this kind of place, but you can grow goat. Okay, they don't need water. Goat. So you look at them, but they don't have many peas. I mean the goat. Okay. And their faces is quite solid because they don't drink too much water. But this kind of survey is quite suitable for growing jojoba. Another kind of interesting plant is dove saltwort. It can be irrigated solely with seawater. They don't need fresh water to be irrigated. Understand? You can watering with seawater directly. Okay. And if we look at biomass and its usage, for example, the monosaccharide, the glucose is for energy and biosynthesis, as we learned in our saying biology or biochemistry lecture. Or the starch is for storage, for quickly releasing glucose, right? For example, rice and a potato, okay? And pectin. Pectin is do you know, fruit is rich of pectin. Because pectin is kind of starch, another form of starch. They will bind water. So that is why your fruit tastes so watery. Understand? So pectin is good for keeping water, okay? And oil is also for storing energy, and the cellulose is to grow to resist gravity, because the plant need energy to grow upwards and to absorb more sunlight to perform photosynthesis, right? So cellulose is quite important for a terrestrial plant, for a tree, but not for algae. Understand? So algae doesn't need cellulose, doesn't need to synthesize cellulose. So algae can grow very fast. Understand? So you can see that is why seaweed can grow. For example, here showing here is the kelp in the Caribbean Sea. It can grow over 20-meter height. They don't need to care about the gravity because they are floating in the water. Understand? So they grow very fast. So considering the productivity, algae is even higher than palm. Okay? Algae is the champion. And if you want to grow microalgae, we should, for the lipid, we should multiply the speed of biomass productivity with the lipid content. So some people say some microalgae will carry about 70% or 50% of lipid content. They are so oily, but the growing speed is not enough. So the best one in terms of the lipid productivity will be still chlorella. We call it 绿藻, okay? Okay, and finally, let me introduce some toxic oil plant. This one is perhaps the most toxic one. It will carry this kind of high toxin. It's called resin. Okay. And the resin is it can inactivate ribosome, and it can be served as a bioweapon actually. But this is water-soluble protein, so the oil is edible. So actually, in southern Taiwan, we got the plantation of, we call it Bimua, in the Kending area, the national park. We got the plantation of Bimua, and we retrieve oil from the plant, and also the fiber. But the fiber is not edible because it contains resin, okay? And cultivating castor, you don't need to use pesticide because it's so toxic, okay? But be careful not to eat this kind of plant. And the other kind is cottonseed oil. To obtain the cottonseed oil, you should be careful because the oil will contain the gossypol. Gossypol has several physiological effects. It can inhibit hydrogenase. It can be served as an oral contraceptive, and this is anti-malaria. Maybe it is a good one. And it is insecticide. It can kill insects, and it can inhibit the replication of HIV. So maybe gossypol is a good solution. In medicine, okay? But the oil may contain this kind of harmful molecules. So actually, the oil is a high quality oil, but it should be carefully purified to become an edible oil. Understand? And the last one in this lecture is jatropha. It's actually a flowering plant. Did you know there are many, how to say it, 油桐花, during the late spring, about May or June, we got a blossom of 油桐花, but a similar version of 油桐花 is this one, jatropha. And they carry this kind of oil seed, and they are high productive, and they can survive on arid area. You don't need to irrigate. But for rapid growth, you need a plenty of water, even higher than sugarcane and corn. So some people, some scholars highly recommend this kind of plant, but I don't recommend it. Because in Taiwan, sometimes we lack water, sometimes we don't have this kind of water resource to cultivate jatropha. But the situation will be totally different in Indonesia. They are rich in water. They are raining. It is raining every day in Indonesia, so they don't need to worry about the water. So here is the a post by Japanese troop to promote the growing of jatropha, and the Japanese army take this the seed of jatropha seed to extract the oil to be served as their fuel for diesel engine. Understand? So it can be used in the conventional diesel engine, and it is easily to be obtained in Indonesia. Okay. And also in the Bali, Indonesia, they have a Hari Raya. What is Hari? It's National Day. National Day. National Day called Nyapi. Okay? Like a New Year's Day. Like a New Year's Day. In the New Year's Day, they have no light, no fire, no working, no traveling. They do fasting, no revelry, no gambling, okay? They just keep calm and stay at home to celebrate the New Year Eve. I think that is the good thing in the modern world, because we are already using too many type of energy, too much resource. We consuming too much. And this is another way to green our planet, not only by using biodiesel or solar cell or wind turbine, something like this. We just keep calm and stay at home to save our planet. Thank you very much. Any question about today's speech? Yep.
I would like to ask if there is an estimate for when biodiesel will become mainstream or popular in Taiwan or globally.
Sorry?
When is there an estimate when will biodiesel
Biodiesel.
become popular?
Yeah, actually, the use of biodiesel, the production of biodiesel is decreasing in Taiwan because our government are focusing on the solar cell and the wind turbine. I guess maybe this is not a good idea, because we cannot compare with the nation like U.S. They have desert, they have land. We don't have land. We need land, actually. We should keep our land green. So maybe we should buy, for example, green electricity from Malaysia. I guess that's our only solution. You know, but okay, growing oil crop is a good idea, but not the only solution. Okay, maybe for example on arid region like the southern, the mountain show earlier, you can grow jatropha or something else to facilitate the productivity. Okay, maybe. So I guess all is about a balance, not to emphasize one item too much.
I'm considering of the waste cooking oil from the EPA data.
Yeah.
Why need to export to the other country? Is it more economy or?
That's the problem of our government.
So it's also a
Yes,
problem
yes.
of the government.
We should promote the use of waste oil, right? So it is the outcome, but I guess it's the defect of our policy. We should promote recycling from, for example, from night market, right? So I guess recycling is the best solution for all. We should do recycling rather than developing something else, developing solar cell, developing wind turbine, or even biodiesel. Okay? We should consider how to recycle everything to be reused as material or energy. And we should do less. The activity, for example, fireworks. Why should we certainly need fireworks? That's the waste of energy, right?
Thank you.
Any question about today's speech? If you got any further question, you can email me, okay? Okay. So thank you so much for your attention. どうもありがとう. So see you someday, okay? Bye bye.